Hello, before jumping into discussion, first let me verify that live is working fine or not. Jumping into discussion, first let me verify that live is working fine or not. Jumping into discussion, first let me verify live is working fine or not. Yeah, so I think we can start the discussion from the first problem of today's LeetCode Weekly contest. 464. The first problem is the GCD of odd and even sums. So what is the problem statement? Problem statement is that you are given an integer n. Our task is to compute the GCD of two values. So what will be the two values? First will be the sum of odd. So the sum of the first n odd numbers. This will be one variable, and another variable will be sum of even. The sum of the first n even numbers. So return the GCD of sum of odd and sum of even. Correct? Now, let's see example. Suppose n is equal to 4. That means uh, the first four odd numbers will be what? 1 will be 1, next will be 3, next is 5, next is 7. This is the uh, first even odd numbers, and the first four even numbers will be 2, 4, 6, 8. Correct? So this will be what will sum? Sum will be 1 plus 3 plus 5 plus 7. So this is ultimately 1 plus 3, 4, 4 plus 5, 9, 9 plus 6, 7, it is 16. Similarly, for sum of even numbers will be 2 plus 4 plus 6 plus 8. It will be 2 plus 4, it is 6, 6 plus 6, 12, 12 plus 8 is 20. Now we have to return the GCD of 16 and 20. Correct? So GCD means the largest number, the answer will be the largest number that actually divide the both the numbers, right? So x is our GCD. That means 16 will be divisible by x. Also 20 will be divisible by x. Correct. So we have to compute the maximum x. Okay. So like 1 will be one GCD. Yes. 2 is possible. One possible GCD. Yes. Because 16 by 2, yeah, it is divisible. 20 by 2, it is also divisible. 3, no. 4, yes. 16 by 4, it is divisible. 20 by 4, it is also divisible. So 4 is one possible answer, right? 5 not possible. 6 is not possible. So ultimately you can see the GCD of 16 and 20, it will be actually 4. Correct? So our answer for this, it will be 4. Now, how can actually do this? So we need actually two variables. One is the sum of odd, that will initialize 0, and sum of even. Okay. So I know the starting odd number will be 1 and starting even number will be 2. Correct? So first of all, I know that I have to take only the first n odd and first n even numbers. So first of all, I will add this into the sum of odd. Okay. So next odd number will be 3. Okay. So this even number will be added to the sum of even. So this will be 2. So next even number, it will be 4. Okay. So I will add 3 into the sum of odd because I have to take, suppose n is equal to 4. So I have to take the first 4 odd numbers. So this is 1 plus 3. This is the first two odd numbers. Next will be 5. So I'll add this 5 into this variable. Next odd number 7. I will add this into this variable. Similarly, I have already taken only one odd even numbers. So next odd even number will be 4. So 4 will be added to here. Next even number it will be 6. So 6 will be added here. Next even number it will be 8. So 8 will be added in the sum of even variable. So I actually I have two variables. One is the sum of odd, another is sum of even. So now I can actually call this GCD inbuilt library function that is already present. Or actually pass two variable a comma b. So it will actually return the GCD of these two numbers. So I'll call that, and I'll return the whatever actually GCD I will get. So you can just hear that the code of this. So this is sum of odd, initialized is 0, and sum of even, that is initialized is also 0. Now I know the starting odd number will be 1, and the starting even number it will be 2. But so I also know that I have to take only the first in numbers. So that's why I will start from 0 and less than n. So that means I will actually take only first in numbers. So first odd number I know that will be actually 1. So that will be added into the sum of odd. Correct. Similarly, the current even number, whatever current even number actually I have, that is 2 initially. So that will be added to sum of even. Correct. And now we have to compute the next odd and next even number. So how can I compute that? You can just see the pattern. I know the first odd number, it will be 1. Next is 3. Next is 5. Next is 7. Next is 9, in this way. So what is the actually difference? Here is plus 2. Here also difference plus 2. Here also difference plus 2. Here also difference that is actually plus 2. Correct. Next is so I know that whatever the current odd number actually I have, so next odd number will be x plus 2. Correct. So next, uh, so similarly for the even number also, the first even number it will be 4, 2. Next even number it will be 4. Next even number it will be 6. Next it will be 8. Correct. So here's what is the pattern. You can just see that if I add the plus 2 again with the previous number like 2 plus 2, so I'll get 4. 4 plus 2, I'll get 6. Got it? So that's why I know whatever the current odd number and current even number actually I have. So I can easily compute the next odd and next even number. So that will be the plus 2 of the current number. Right? So that's why before going to the next number, so I will calculate what is the next odd number and next even number. So that will be odd plus 2. Whatever the odd number currently I have, that will be added to plus 2, and whatever the current even number I have, that will be added plus 2. Got it? So in this for loop will run n times. Correct. So I'll only take the first in odd numbers and first in even numbers. After that, what actually I have to return? I have to return the GCD of sum of odd and sum of even variable. So I'll call this inbuilt library function GCD. I will pass these two variables, sum of odd and sum of even. Got it? So this is actually the simple approach. Now, here they mention on hint. So there actually you can solve it a different way also. How? So I know that odd numbers will be 1, 3, 5, 7, 9, 11 in this way. Correct? And even numbers will be 2, 4, 6, 8, 10 in this way, right? So if actually just take out the common number 2, so that will be here actually it will be 1, 2, 3, 4, 5. In this it will continue. So ultimately, if I want to sum up all these numbers, so that will be 2 into, here actually just a pattern, 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that means it sum will be what? N into n plus 1 by 2. So that means n into n plus 1 by 2. So ultimately 2 will be cut, and ultimately sum will be n into n plus 1. This is for even numbers. For even numbers, I can easily calculate the sum of this. So only for odd numbers, 1 plus 3 plus 5 plus 7 plus 9 plus 11. So here actually you can see 1 plus 1 plus 2. Then it actually 3 plus 2. Correct. Then it actually 5 plus 2. So easily you can write here also with 3 plus 2. 1 plus 1 plus 2. Similarly, for 3 will be written as a 1 plus 2 plus 2. Clear? This is ultimately 5. Next is 5 will be again written to this format 1 plus 2 plus 2 plus 2. Got it? So you can just see here that how many actually a 2 will be repeated. So you can just say pattern. This will be ultimately n into n. So that means 1 will be present how many times? N times. For each number actually I have actually one element. So and ultimately how many actually 2 will be present? 2 will be present as here actually it will be present only once. Here actually 2. Here ultimately 3. Got it? So that means 1 plus 2 into 0, 1 plus 2 into 1, then ultimately 1 plus 2 into 2, 1 plus 2 into 3. So this number is ultimately 1, this number is 3, this number is 5, this number is 7. Got it? Just follow the pattern, then it will be easy to understand. So ultimately, if I want to sum of this, so 1 will be n times, this 1 will be present n times, correct? 1 into n. And for this 2, how many 2 will be present? 2 into 0 plus 1 plus 2 plus 3. In this will continue. So how many times actually 2 is present? Almost 3. But that actually ultimately n minus 1 times. Correct? So that is ultimately 2 into 0 plus 1 plus 2. This will continue ultimately n minus 1 times. So 2 into, here actually you can just follow the pattern 0 to, that means 1 to n minus 1. Correct? So here it will be n minus 1 into n minus 1 plus 1 by 2. Clear? So 2 will be cut. So you can just hear that n minus 1 into n. Got it? And from 1 into n, I already got for this 1, and this is for 2. So ultimate total sum will be for odd, that will be 1 into n plus n minus 1 into n. So if I again common out this n, so it will be 1 plus n minus 1. So 1 will be gone. Ultimately, I will get n into n. This is clear. So for odd, I will get n into n. For even, I will get 8 into n plus 1. Correct? Now, what is GCD? GCD means the largest common numbers that actually I can divide both the numbers. Yes. So here actually which number actually I can divide with which number? N will be divide both the numbers because both the numbers actually have ultimately n. One is n into n plus 1, another number is n into n. So I can divide both the numbers with n. So that's our answer will be n. So that's why I can easily return n without computing this ultimately GCD or sum of variables. Clear? So if any doubt, you will comment now before going to the next problem. Now let's go to the next problem. 3659 partition array into k distinct groups. So you are given an integer array nums and integer key. Your task is to determine whether it is possible to partition all elements of num into one or more groups such that each group contains exactly k distinct elements and each element in nums must be assigned to exactly one group. Return true if such a partition is possible, otherwise return false. So that means we actually have some numbers, array of numbers. So that means actually you can see 1, 2, 3, 4. 1, 2, 3, 4 and k is equal to 2. That means what they're trying to say that we have to create the groups, or actually each group actually have exactly two elements. So how many number of elements actually I have? That actually 4. So how many groups actually I can create? That will be total n by k. So 4 by 2 by 2 it will be 2. So two groups actually I can create, right, from these four numbers, because each group actually have k distinct number. So that's why it will actually have ultimately 2. So each group actually have two elements. So total number of groups it will be 2. Clear? N by k. Now, so I know that this is the two groups actually I have to create. Okay, this is the suppose G1, this is suppose G2. Now, from here, so what they're trying to say that next condition is that we have to check that each group contains exactly k distinct element. So whatever actually the uh, uh, number actually present in one group, that should be all the should be unique, right? And each element in nums must be assigned to exactly one group. So that means all the numbers should be present in any one of the group, and the number of groups will be 1. So actually suppose I have actually assigned 1 here and 3 here and 2 and 4 in this group 2. So now let's see, is it uh, satisfying the condition or not? The first condition is that the number of the k number of distinct elements should be present. So here actually you can see that two elements are present. All those two are actually unique. Okay. Similarly for here also, all those two numbers actually present. All those are actually unique. Okay. Next, they mentioned that all the numbers should be present in exactly one group. So okay, one is present in group one, two is present in group two, 3 is present in group 1, this 4 is present in group 2, correct? So this is also ready. So I have to return here say true, correct? Next is suppose another example, this negative test case 1523. So 1523 k is equal to 3. That means I have to create that any number of groups that should actually have k number of distinct element. So how many group actually I can create? So actually in each group I have we should have actually 3 number of distinct elements. So here's the total number of actually elements actually I have, that actually n is equal to 4, and each group should actually have 3 distinct elements. So that means I can create only one group that actually have 3 elements, another group will be only 1 element, right? So this is not actually valid test case. Why? Because they mention that all the groups should actually have exactly k distinct elements. So okay, suppose I actually have 1, 2, 3 here, and I have placed 5 here in this group 2. So in this group 2, do we actually have k number of distinct elements? No. So that's why I have to return false here. Correct. So to check, the first condition is that to create the k number of like group, that those every group should have actually k distinct elements. So what actually you have to validate? You have to check that n modulo of k should be equal to 0, because the number of groups I can create, that is actually n by k. So if it's not divisible by k, that means some group actually have less number of elements, less than k number of elements. Okay, so that's why that time I can easily return false. So if it is not, if it is true, then okay. If it is else, if it is false, I have to return false. Okay. So if it is true, okay, no problem. this first condition is clear, the case one, when actually when actually I can't create k now, the groups if or actually each size of the group is actually k. Okay. Next, this case is clear, so I can directly return from here actually false if it is not divisible by k. Now next case is suppose k, suppose 1, 1, 1, 1, 1, 1. So k is equal to 2. Okay, so n is equal to 6. Total 6 element actually is present. So n modulo of k, it is equal to 0. This is true. So I will not from here. I will not return from here. So how many group actually I can create? N by k. So that actually ultimately 6 by 2 it is 3. 3 groups will be created. Suppose this is group 1, this is group 2, this is another group 3. Group 1, group 2, group 3. So here actually, suppose I have placed 1, 1. Here also I have placed 1, 1. Here actually I have placed also 1, 1. So is this a valid test case? No. What they mention? They mention that what are the numbers actually present in one group? All the numbers should be unique. So k number actually present. Okay, 2 number actually present, but all the numbers should be unique. So is the all the numbers here actually it is unique? No. So that's why I have to return from here false. So how can I identify that I have to repeat some number in some group? So that means here actually you can see that I have to create 3 groups. I have to create 3 groups. Okay. So if our one number of 1 is greater than 3, then some that extra 1 should have to place in any one of this group. Either it will be group 1, either it will be group 2, or it will be group 3, right? So that's why I will check that I need actually one counter, right? The frequency of 1, suppose here actually it is 6. Okay. So I'll check, I know that how many groups I can create. Number of groups I can create, that is 3. But the count of 1 actually is 6, that is greater than 3. That means in some place, in some group, I have to place this number again, repeated case, right? So that's why I have to return false. For this case, return as a false. Clear? So when I have to return false, so that's why I will need one frequency map. Or actually, I'll count that. So I can actually easily count that for this number, how many times actually I have seen this number. C1. Suppose Y, I will see that how many times I have seen. Now I know that how many groups I have to create. Okay. So I'll check that if C1 is greater than groups, so that means I can't create this. So there will be some group that will be some repeated element. So that time I return false. Else, if I place all the numbers is if all the numbers is less than number of groups, that means there will be no repeated test case, right? So that time ultimately I return true. So now go to actually code. So first of all, check what is the array size, input array size, that actually n. And I'll check that can actually create uh, groups that actually size each size actually is k. So that how to check that I will check by using if it is divisible by k or not. So whatever the n is present, if it is not equal to divisible by module of k not equal to 0, return false. Okay. So this is to check that this test case 3, example 3, because here actually our group size actually is 3, correct? But we actually have only 4 elements. So I can actually, there will be 2 groups. One will be one group actually have 3 elements, another group will have only 1 element. That is, that second group will be anyways it will be needed, right? So that's why I'll return here from here that false. Okay. Then actually I have to check that for this situation, where actually all the number actually is 1, and there will be some repeated element in some group. So that I have to check. So how to check that? So that's why I have to know that first of all that how many groups I can create. So that will be n by k, right? Suppose here actually you can see that total number how many actually elements is present 4, and each group actually have 2 elements. K is equal to 2. So how many group actually I can create? 4 by 2. Clear? And I need also another map to check the frequency of each number, because ultimately we will check that if it is greater than the group numbers there, then there will be some repeated test case, right? In some repeated element in the sum group. So that's why I'll take another map. So the key will be the number and the value will be the frequency, that how many times I have seen this number. So now iterate the for the input array, that is nums, and I will increase the frequency for each number. Okay, in the map actually increasing the frequency by 1. Then after uh, getting the frequency of all the numbers, I have to check that if this frequency what actually I have, that is greater than groups or not. If it is greater than groups, then so I'll check the value. Value means the frequency of the current number, any number, it may be any number, x, y, z. If the frequency of that number is greater than the number of groups, then I have to return false. So if there is no such situation, so ultimately we will return true. All right, because I can actually place all the numbers in different groups, or actually all the number actually is unique. Clear? So I hope this is clear. So you have any doubt, you can comment on this here. Let's see the hints also. How many groups of size k you need to form? Yes, that will be n by k. Each group must contain exactly k distinct elements. Okay. If any element appears more than times the number of groups, it cannot be placed innately in each group. Yeah, that's why we need actual frequency map here. Next hint is use a frequency map frequency to count the occurrences of each element. If the total number of elements in is not divisible by k, partition is not is impossible. Here actually the example 3. Because there will be some group whose size will be less than k. Right. Here actually you can see the second group will be have only one elements. Okay. So bye. Thank you.